Hi everyone, welcome back to Abra Knowledge channel. Today we are going to discuss binomial distribution. We are going to do it in Excel, and particularly in Excel we are going to do it in using the formula, and there is a powerful add-ins called ToolPak. I'm going to describe that also as well. ToolPak, with the help of ToolPak also we're going to do it, and within the Excel as an add-ins, and then we are also going to compare the result in Minitab also as well. And this one is coming from the book called Statistic for Manager using Microsoft Excel 8th edition. It's a Pearson model. There are three scenarios we're going to do it. As I said that we're going to do it in Excel as well as Minitab. Let's get into the data set. So this is my data set I have. So we are going to discuss binomial distributions. Okay. And binomial distribution, as you know, that is all about defective, yes or no, pass fail, all called binomial. Bi mean two, right? Yes or no, right? On and off, right? All these we're going to discuss. Input and output. This is the input. So input binomial, we need to have a n. And what is the probability? Probability is being described always in decimal like this. For example, if it's 60%, we're going to write it 0.6. If it's 5%, 0.05, and so on. And what is the probability you're going to, what is the random things we're going to talk about it, or what is the x value we're going to describe it. Okay, this is the scenario which we are going to discuss in this video. And in this one, we are also going to discuss the formula very importantly. And let's see that, the scenario number one. Researcher noticed that 60% of the VSR owner understand how to program their VSR, putting the Binomial process 3 randomly selected. So that means 3 is randomly selected. What is the probability that exactly 3 trials are there? So 3 trials, 3 out of 3 is being selected, and then what is the probability they get? 60%. If it is 60%, if they're going it, that means they have a chance of winning 21.6%, right? So if you want, you can convert into 26 percentage also as well, right? So 20, then I'm just going to convert back to decimal. So that means 21.6% we are going to get it. And then similarly, the scenario number 2, a manufacturing company regularly conducts the QC check. Historical failure rate is 5%. That means 0.05. And then suppose a random sample of 10 bulb, n equal to 10, is selected. What is the probability that none is defective? That means 0. None is defective. That means 59% they are going to get it, or 60%, because this is almost 60% of the failure they are going to get it, right? I'm going to convert into number back. Precisely 59.87. And then exactly one of the LED is defective. So 10 sample, one is been drawn a sample, and then one. That means 31% they're gonna have. If it is 2, that means they're gonna have like 7.46. And here the question is not only 2 are fever of the, fever. That means we should add all these things together, right? So whole value we are getting like 98. So this is 98. Maybe I will just change it. So 98 we are getting it. How we are going to get it? So 2 are fever of the LED. So 2 are fever. So 2, and you need to count, and 1 and 0. So 98.85. And then 3 are more. 3 and more is actually you have until 4. So 3 or more, you're gonna get it like 0.0114 or round up to 0.115, right? So this is how we can easily get it. And then I will quickly describe the third scenario, and then I'll come back to the formula and add-ins. And according to Verto Analytics Incorporation, 53% of 30 to 34 years old US citizen holds the latest laptop, and the impact of income and age to be determined. What is the probability that 4 will own? So you know that 6, and we are going to talk about 4 probability, and then 53 is being converted into 0.53, and this is the 26%. If it is 6, then you have 2.2%. If it is at least 4 will own. At least 4 meaning like, again, you are going to do it like at least 4. You are going to do it like all these together, right? 6, 5, 4, and all that. Right? This is what you will get it. So this all this you will be doing it 40.15, and at least 3 or fewer will own it. 3 or fewer. So that means all these lower. That means 59 percentage, right? This is how we can easily do it with the help of Excel. And let's see that formula. The formula is actually you give, maybe I will take this one, give equal to binomial, right? Binomial distributions. And you can use a two formula. Here I have used binom.distributions or binom. So I will use the same formula again, binomial equal to binomial distributions. Okay, the first one. Here actually the number is, I have selected the number, and then probability also selected, and then how much trials, right? And n, right? So that is also been selected, comma, and probability mass function, cumulative function. So I'm gonna select mass functions. Okay, give, close this one and give okay. Okay, I have not selected the D column. So this is not selected. Maybe I will do it one more time. Equal to binomial distributions and numbers. So number equal to, this is the number. So C5 is the number. So C5 is selected, comma, and then you have this one is in the B5. So B5, right, comma, and then you have A. A is there in A5. A5, comma, and then this is a false value, and then give okay. This is one. I mean, I will select the value again, binomial distributions, and so this is the value, and then you have a n equal to 10. Sorry, the after this one n equal to 10, and then what is the probability, right? And then false. Now it should, you will get the value. Okay. So you got this value. So last time I swapped this value, that's the reason it didn't come. So you can easily remember its cap, right? First you need a, what is the number, so random you're going to take it, and what is the oral number, and what is the probability. So cap you can remember CAB, C for the number, and in this cap CAB, cap is a X value gonna feed it, and then A is the number, and B is the probability, right? Exactly in the same thing you can do this also as well, right? You can just simply copy paste this formula, you will get the same value as such. I will undo it. Let's do it again. Binomial, and this is C, this is C, A, and B, and you have false. Yeah, and I'm just checking this formula. This is perfect. This is CAB. This is perfect. C7. This is perfect. CAB, and this is perfect, right? And the similarly, we can also do it this also as well. So in this case, equal to binomial distributions, and first is the number. So C10, comma, CA, and n is been found out, and then probability. Here in this case 0.53 is the probability, right? And comma, and then I'm going to give false, give okay. So you got this one, and similarly you can get it. So you can also do it with the help of add-ins also as well. How to do it? Go to file and go to options, and then you have something called add-ins, right? In the add-ins, you see here analytics analysis tool pack, and you can give go, and you can install this analytics one, and you can install it. Once it is installed, what we can do is we can same thing. We can also do it with the help of syntax also as well. For example, I'm just going to formula, and I'm going to go with the more function in a statistical, and then we're going to do it binomial distributions, right? So here we can easily feed it. So here number, so number example 4, and number of trials, right? You can easily fetch this value also as well if you want, right? So in this case 0.53, and maybe I will also fetch this value also as well, number equal to 4, and C10 B10, and then probability. Probability is, sorry, number of trials, this should be number, okay? And then this probability, this is the probability, and then you also have that false value, right? So you can give, right? So automatically it gives this value. Let's say we give 1, it gives this value. Automatically it gives this value. We always keep false. And similarly, you can also, if you wanted to do it other value, let's say you don't want to bring this one, you can also do this also as well. For example, let's say, let's take this example, row number 11, we'll take this example. So what I will do first is number is 6, and followed by trials is also 6, and and then 0.53, 0.53, and you will get this value. Automatically you got this value. So that way also you can do it, right? It is very simple, and it is very and yet it is very interesting. If you would like to do it with the help of this, you can do. The only thing is you need to go to all function, statistical, and in this case we are doing it binomial distributions, and you can feed this value. Either you can inherit this value. For example, in this case, let me take the last or the first value example, numbers. So in this case, this is my number enter, and trials. So in this case, the trials are 3, and then probability is 60%, and then you can give false, right? 0.216, exactly the same thing. Let's do the same thing in Minitab also as well. So I have opened up this Minitab, and go to graph, and go to probability distribution plot, and the last one, view probability. This is what we're going to use it. Give okay. And in this case, I have already selected binomial distribution, number of trials. So in this case, number of trials is 3. Example, the first one is 3. Number of trials is 3, and even probability is 0.6, and then shaded area. And what is the n value? N value also equal to 3. X value also 3. Give okay. So exactly it is matching, right? So 3, if it is 3, you have 21.6%. If it is x equal to 2, 43%. If it is x equal to 1, if your randomly 1 is being selected, then x value also you get 28. If it is 0, 6.4%. Easily you get it. Similarly, we will do the second exercise. Control E. I'm going back, and the 10 sample n equal to 10, and 0.05, 5%, 0.5, and shaded area I'm going to shift. So I will start with 0, 0, give okay. If it is 0, what is the value? 59.87. Exactly 59.87. If it is 1, you already have that one value, 31.51. Exactly. If it is 2, you can also get this value for 2. 7. If it is, again, you have this 3, 10, right? I mean 1.05. And all these values. So exactly we have already tested. Maybe I will just put that value called 3, right? So control E, shaded, I'll keep that value as 3. 3.0, exactly the same value we have got it here. If it is 4, control E, and then I'm keeping like 4. If it is 4, exactly the same value we have got. Let's do the last exercise in Minitab, right? So I'm going to give Control E, and the 6. So number of trials are 6, and event probability is 0.53, and shaded region. In this case, I'm gonna keep it like 4. 4 will own a laptop. 4 x equal to 4. Give OK. 26.14. 26.14. If it is 6, let's go for 6. Right? 2.21. Right? Exactly 2.21. Exactly it is matching. If it is 5, you already have 5 here. 5 values here. 5, 11.79. 11.79. If it is 4, we have already got it. If it is 3, so if it is 3, 30.9. If it is 2, let's see, 20.5. Exactly. If it is 1, you also got 7 percentage, right? If it is 0, you got 1 percentage. Exactly the same value. I hope you enjoyed this video, and binomial is all about defective. In the control chart, one small input, in binomial distribution P chart and NP chart, it uses that binomial distribution. And you also have a Poisson distributions. Poisson distributions, we are going to do it in the upcoming videos. And I hope you enjoyed this video. Please do like, share, subscribe my channel. You have a wonderful day ahead.